Hello everyone, we are Group 12 and today we are going to give the Vodcast for Mathematics 123. The application we are going to talk about is the derivatives. In order to make our work detailed and understandable, we will talk about the background, the definition, the formulas, and give the examples for how to use it. What we call derivative is an essential tool of calculus, and it's a fundamental topic in some areas like mathematics, engineering, and physics. The definition of derivative is when we suppose y equal fx is a function. The instantaneous rate of changing of y at x equal a is something else. If this limit exists, the value is denoted by symbol f comma a, and this calls the derivative of y at x equal a, and the process to find the derivative is called differentiative.
There are lots of applications of differentiation, including finding the gradient, the maximum and minimum points of the stationary points, and the second derivative. The application we are focusing on today is the findings of coordinates and types of stationary points. Firstly, I'm going to introduce some of the most common rules of the derivatives.
Here is the example of finding the coordinates and the nature of stationary point. To find the stationary point on the curve y equals to 12x to power 5 plus 5x to power 6 plus 1 and find the nature of the stationary point. First of all, we need to define dy divided dx equals to 60x to power 4 plus 30x to power 5. Now, we know stationary points that gradient would have to be 0, which is dy divided dx equals to 60x to power 4 plus 30x to power 5 equals to 0 in this case. If we factorize this, we could put out 30x to power 4 as a common factor, and inside the bracket it would be 2 plus x. Then we have x to power 4 equals to 0 or 2 plus x equals to 0. Therefore, x equals to 0 or x equals to minus 2. Now, we have to find out when x equals to 0 or x equals to minus 2 respectively. Substituting x equals to 0 into the original function, y equals to 1. When x equals to minus 2, y equals to 63. We can roughly sketch a coordinate of this function, in this case to help us explain what's going on in this particular question. Hence, there are two stationary points, 0, 1 and minus 2, minus 63.
From the latter part, my partner already given out the coordinates of the two stationary points. And the second step is to second derivative the function and put those 2 points into the function. When x equals to 0, the result of the second derivative function is 0 as well. So the point 1, 0 is an inflection point. And when the x equals to negative 2, the result should be 480, that bigger than 0, which means that the original function should have the minimum result, which shows a positive trend curve. And the point negative 2, negative 63 is the global minimum point. That's all the information for our Vodcast, and thank you so much for your patience and your listening.